Okay, so today we will talk about exponential functions. Okay, so what's exponential functions? So we have f of x is 2 to the x. Okay, 2 to the x. So here the base is 2 and the base is fixed. Okay, so fixed base number 2 and then we change the exponent. So exponent is x. Okay, so we can pick any value for the exponent. Okay, exponent. Now let's choose some small integers for the exponent, right? Exponent. So this is the x, so we choose x is 2, x is 1, x is 0, x is -1, and x is -2. Okay, so these are the inputs of the functions, 2 to the x power. Okay, this exponential function. So these are the input. So now what's the output? Output is f of x is 2 to the x. So f of 2, x is 2, so it's 2 squared. This is 2 times 2, 4, right? 2 times 2, 4. So this is the input, this is the input. Okay, we replace x by number 2. And then the second one, f of 1 is 2 to the first power, so 2. Okay, same base, and then we change the exponent. So f of 0 is 2 to the 0's power is 1. So this is the definition, right? Any number to the 0's power is number 1. Okay, number 1. And then we have negative exponent. So f of -1, so this is 2 to the -1's power. So we flip, right? We flip, so this is 1 over 2 to the first power. So it's 1 over 2. F of -2, so this is 2 to the -2's power. So we flip it, we got 1 over 2 to the second power. So this is 1 over 4. Okay, so this is 1 over 4. Okay, so in our first example, base is fixed, and then we got these 5 inputs and output. So if we put input output together, we got 5 points, right? 5 points. So point A is input to output 4, and B is 1, 2, C is 0, 1, D is -1 and 1/2, and E is -2, 1 over 4. Okay, 1 over 4. So now we can plot A, B, C, D, E to draw the picture, to draw the graph of this exponential function. Okay, yeah. So 2, 4. So here is 1, 2, and go up 4, so it's somewhere here. So this is my A, right? 2, 4. My B is 1, 2. So when input is 1, the output is 2. And then 0, 1. So 0, 1. So here is 1. So this is 1, 2. This is 1, 2, 3, and 4. So this is number 1. So this is our point C. Okay, our C is 0, 1, right? 0, 1 on the y-axis. And then -1/2. This is -1, -2. So -1/2 is here, and -2, 4. So this is D, and this is E. Okay, this is E. So now let's draw a red curve from A to B, B to C, C to D, and then D to E. So this is the graph of function f 2 to the x power. Okay, 2 to the x power. Okay, so later I will tell you the properties for the exponential graph of exponential function. Okay, so now let's look at another one. Okay, so let's change base 2 to base 1/2. Okay, base 1/2. So f of x now is 1 over 2 to the x power. So let's use, okay, 1/2. Okay, so let's write down base. Base for this exponential function is 1/2, is fixed, and the exponent is the input x. Okay, input x. So we choose the same input, right? Same input. So it's 2, 1, 0, -1, -2. And then f of x, so this is f of 2 is some space, so let's delete this line. So f of 2 is 1 over 2 squared. So this is 1 over 2 times 1 over 2, 1 over 4. F of 1 is 1 over 2 to the first power, so it's 1 over 2. F of 0 is 1 over 2 to the 0's power is 1. F of -1 is 1 over 2 to the -1's power. So now we flip. So this is 2 to the first power. Okay, so we just flip the base. So you can flip the base or you can flip the whole power. Okay, you will get the same thing. Okay, you will get the same thing. So this is number 2. F of -2, so this is 1 over 2 to the -2's power. So flip again, so get to 2 to the second power. So this is 4. Okay, so this is 4. So we got 5 new points, right? 5 new points. So for this one, A is 2, 1 over 4. B is 1, 1 over 2. C is 0, 1. D is -1, 2. And E is -2, 4. Okay, so let's plot A, B, C, D, E. So here is A. A is 2, 1 over 4. So go up a little bit. So this is A. And then this is A, 2, 1 over 4. 1, 1/2. So here is B. Right? And then C, 0, 1. So still 1 here. So this is C. And then -1, 2. So here is D. And then -2, 4. So here is E. Okay, here is E. So now let's draw a curve. So E to D, D to C, C to B, B to A. Okay, B to A. So this is the graph of 1 over 2 to the x. Okay, to the x. Okay, so this is our second example. Base is 1 over 2, and then exponent is x. Okay, yeah. So we choose 5 inputs, we got 5 outputs, and then we got 5 points, and then plot the point, you got the picture. Okay, you got the picture. So now let's put the properties. Okay, properties. So f of x is a to the x. Okay, a to the x. So we'll assume a is positive. First case, if a is between 0 and 1. And second case, if a is bigger than 1. Okay, bigger than 1. Okay, so what's the common part? The common part is the y-intercept. The y-intercept is always 0, 1. Because a to the 0's power is 1 for any positive a. Okay, for any positive a. So now we know the graph. You both have y-intercept 1. Okay, so 1, this one is on the graph. Okay, 1 is on the graph. So now the property, if a is bigger than 1, then the graph is going up like this. Okay, so this is for big A. A is bigger than 1. Okay, bigger than 1. So if A is less than 1, bigger than 0, positive, so this is the graph. It's going down. Going down like that. Okay, so this is the graph of exponential function. Okay, a is bigger than 1, go up. A is less than 1, go down. If you look at the whole graph from left to right. Okay, whole left from left to right. And then another property is the output is always bigger than 0. Okay, yeah. So f of x is always bigger than 0. That means the whole graph always in the upper half plane. Okay, upper half plane. So there's nothing in the lower half plane. Okay, lower half plane. Okay, so f of x is always positive. For both cases, right? So a could be bigger than 1 or less than 1. A is positive, so all the powers of a is positive. So the input can be positive and negative. Okay, input can be positive. So now when a is 1, what we will get? Okay, when a is 1. So if f of x is 1 to the x power, so this will be 1 for any x. Okay, for any x. So that means for any x, the output is 1. Okay, yeah. So if you draw the point, so that's to x to be the input, also 2, 1, 0, negative 1, negative 2. So what's f of x? Is always 1. Okay, and then what's our point? 2, 1, 1, 1, 0, 1, negative 1, 1, negative 2, 1. Okay, negative 2, 1. So what's the graph looks like? The graph is a horizontal line past 1. Okay, past 1. So this is A, 2, 1. This is B, 1, 1. This is C, 0, 1. This is D, negative 1, 1. And this is E, negative 2, 1. Okay, so f of x is 1 to the x is a horizontal line. Okay, it's a horizontal line passing through 1. Okay, passing through 1. So again, y-intercept is always 1. Okay, it's always 1. Okay, so when you practice online, you may have some other examples, harder examples, like f of x is 3 2 to the x, 3 times 2 to the x plus 1. Or maybe f of x is negative 3 times 1 over 2 to the x minus 1. Okay, yeah. So we always choose x to be 2, 1, 0, negative 1, negative 2, and then we find f of x, and then we find 5 points. Plot the points, you can get the picture. Okay, you can get the picture. So here something is wrong, so this should be x. There's x here. Okay, x here. Okay, yeah, and then if a is bigger than 1, so this one, the graph should be something like this, going up. And this one, a is between 0 and 1, so it is going down like that. Okay, going down like that. So that's the graph part. Okay, that's the graph part. Okay, so the second part of today's lecture is the equation. Okay, so exponential equation. Okay, equation. So let's look at our first example, right? 2 to the 3x power is number 8. Okay, is number 8. Solve for x. Okay, solve for x. So what's the key idea to solve this kind of equation? Change both sides to same base. Okay, we need same base on both sides. Okay, on both sides. So now what's the base for this side? Base is 2. So we need to change 8 to base 2. Okay, we need to change number 8 to a power which has base 2. So what is 8? 8 is 2 cubed. Then we have base 2. Okay, then we have base 2. Okay, so we get a new equation. So 2 to the 3x is 2 cubed. Okay, so that's our step 1. Change to the same base, and then what? Drop the base. Okay, drop the base. So we got 3x is 3. Okay, so we get the same base. That's step 1. And then we drop the base, or delete the base to solve the new equation. Okay, to solve this new equation. So 3x is 3 divided by 3 divided by 3. X is 1. Okay, x is 1. So that's the key idea for exponential equation. So next time we will talk about log. Then some questions we may use log to solve it. Okay, to solve it. So basically we'll change this step. Sometimes we can use the definition of log for step 1. Okay, for step 1. Okay, so now let's look at some verbal questions. Okay, so this is very similar to what we had before, so let's write it down. The question is 3 to the 2x power is 81. Okay, is 81. So now we need the same base. We have to change 81 to base 3, right? Base 3. So if you don't know how to do that, you just keep dividing by 3. 81 divided by 3, 27. 27 divided by 3, 9. 3 is 3, 3. So we have 3 to the 4th power. Okay, 4th power. So 3 to the 2 to the x power is 3 to the 4th power. So that's step 1, and then we drop the base. We got 2x is 4. Then divide by 2, divide by 2, x is 2. Okay, x is 2. So sometimes we have to use the definition of negative power because we have fractions. Okay, we have fractions. So now let's look at the next question. Okay, so this question is a little bit harder. So we got 8 to the x is 1 over 4. Okay, 1 over 4. So first, you cannot use base 4 or base 8. Okay, because you cannot change base number 8 to a power of 4. 4 times 4 is 16. It's too big. Okay, it's too big. So still here we use base 2. Okay, base 2. So that's very important. Okay, that's very important. So we change both sides to base 2. So 8 is 2 cubed, and then 4 is 2 squared. Okay, 2 squared. So we got 2 cubed to the x power is 1 over 2 squared. Okay, 2 squared. So now we have to simplify left hand side, right hand side a little bit. Left hand side is the multiplication rule. So this is 2 to the 3 times x power. Right hand side is definition of negative power. So it's 2 to the negative 2th power. Okay, 2 to the negative 2th power. Then we have the same base on left and right side. So we can drop the base 2. Okay, we got 3x is negative 2 divided by 3. We got x is negative 2 over 3. Okay, negative 2 over 3. Okay, so when we try to use the base, try to change both sides to the base, we mainly use prime numbers 2, 3, 5, and 7. Okay, so mainly 2 and 3 for our class. Okay, sometimes 5. So 2, 3, 5, 7 is prime numbers to be the candidate of your step 1. Okay, step 1. So let's look at one more example, harder example. Okay, so this question on the whiteboard is a little bit harder because this one, we have a radical here. Okay, we have a radical here. So let's write it down. 3 to the 2x plus 1 is radical 3. Okay, radical 3. So now the base we want is 3, right? The base is 3. We want both sides to be base 3. Okay, so you don't need to do anything on the left because it's already base 3 on the right. So what's 3 radical 3? Is 3 to the half power. Okay, so nth root means rational power with denominator n. Okay, denominator n. So nth root of x m's power. So this is m over n's power. Okay, so we get some rational powers for harder questions. Okay, so now I have the same base, drop the base, then we got 2x plus 1 is 1 over 2. Okay, is 1 over 2. Then solve this linear equation, right? Minus 1 minus 1. 2x is negative 1 half. Divided by 2, divided by 2. X is negative 1 over 4. Okay? 4. Okay, so that's the idea. We change both sides of the equation to the same base, and then sometimes we got negative power because we have to flip it, and sometimes we got rational power if there are roots. Okay, if there are roots. Okay, yeah. So now let's look at the last question. One more question about the graph on the whiteboard. Okay, yeah, so for this graph, you have to choose. You are given 4 functions and then 4 colors, 4 graphs. Okay, 4 graphs. You have to choose which one is which one, right? So my suggestion, how to do this question, you have to draw them in the same plane. You just draw them, label them, and then you will see. Okay, you will see. So if the base is bigger, what's going to happen? If the base is smaller, what's going to happen? Okay, so this one, you just try to draw them by yourself. and then look at the picture, you can pick the answer. Okay? Yeah. Okay, so that's our today's lecture.